have a test on Friday. We will review tomorrow. We'll have a test on Friday and we'll review tomorrow. The test is multiple choice, just so you're aware, but it's no work, no credit. Okay, so you have to show your work. You have to understand your work, and if you don't show any work, you don't get credit, regardless of whether or not you got the answer correct. Okay. Work means lots of things, but every single problem, you can write a sentence or write something. If it's a really easy one, I'm sure there's some pencil work you can do where you're just like times by 3, done. Sure, that works for work. Okay, so it could be something really little. Just a little bit of work is fine. Okay. The second period didn't get this work done today, but we have a little bit of a extra thing to deal with in second period. So hopefully you guys will be able to finish it, but if you don't, today is a day you'll get to take it home and finish it for homework if you need to, okay? But I still encourage you to just get it done and get it turned in so you don't have to worry about that. So here we go, solving linear inequalities. This is what we're working on today on this day, August 14th, 2019. Solving linear inequalities. What are inequalities? Less than or greater than. Yeah, inequalities are not quite equal to. So less than or equal to, greater than or equal to, and just less than or greater than. And the nice thing is, really, this is just us solving linear equations more. So it's just more practice with equations, which is why I'm doing this, okay? Just to make sure we all can solve really, really well. So here we go. Example 1, solve the inequality, then graph the solution. Example 1, solve the inequality, then graph the solution. Solve the inequality, then graph the solution. All right. So graph the solution on the problems that you need to graph. It is a simple number line graph, a horizontal number line. And I will model that, of course. We have 6.4t minus 8.1 is less than 12.7. Goal is the same. We need to isolate the variable. What do you want to do first? Add 8.1 to both sides, leaving me with 6.4t is less than 12.7 plus 8.1 is 20.8. And now what do you want to do? Divide by 6.4. Divide by 6.4 on both sides. 6.4 divided by 6.4 reduces to a 1, and 20.8 divided by 6.4 is math I don't do in my brain. 20.8 divided by 6.4 is, my calculator says 3.25, which is good enough for government work. So here is our inequality. It says t is less than 3.25. And we want to graph this. So I'm just going to do a horizontal number line. And for me, graphing is usually pretty easy. I don't require too much. I do say you need to have a 0 on there. So we're going to mark a 0 on our number line. And then what is our important number for our solution? 3.25. And so would that be to the left of 0 or to the right of 0? To the right. So there it is. I'm just going to mark 3.25. That's all I care about. You do not need to sit there and go 0, 1, 2, 3, 4, and then, oh, there's 3.5, and there's 3.25. You do not need to do that, okay? That is a waste of time and energy, okay? So now, if you'll remember, when we're working with inequalities, we have either open circles or closed circles. So at 3.25, should we have an open circle or closed circle? Open. Open is correct. It's an open circle whenever we're using simply less than or greater than. We use an open circle. When our symbol has the extra bar that says or equal to is always solid, a solid dot or a solid line. And so when we have that extra equals to, that's when we use a solid dot. Okay, now, when we are graphing inequalities, it's important that you learn how to read an inequality, which a lot of teachers do not teach you how to do. I don't like just saying T. T represents any number. Any number, so I'm going to say any number, and closest to my any number is this pointy, small side of my inequality. So we say any number littler than 3.25. You always read from the variable side, wherever that may be, from the variable to the number. So we want any number littler than 3.25, which would be which direction? Where are the numbers littler than 3.25? To the left. So we're going to shade to the left. I like to do a squiggly line just so it shows very clearly where we're shading. Okay. Nice big arrow. Is 3.25 a solution? No, it is not. Is 3.249999999 a solution? Yes. 3.249999999 is just skosh to the left, and that is included. 3.25 is not included in an answer. All right, letter B. What's different about letter B? Yeah, we got 3 sections here. We've got 2 inequalities. This is called a compound inequality. Like a compound word, it's a couple equations put together into one. And we basically just need to solve all of these equations simultaneously. When we have a compound inequality like this, we want to isolate our variable. We want the x in the middle. We want the x in between, all isolated by itself, in between our 2 inequality symbols. What do you want to move away first? What? So we want to get this x by itself. What's with it? The -3, yeah. So how do we move that -3? We're going to add 3. And we're going to add 3 on the right-hand side. We're also going to add 3 on the left-hand side. We're going to add it everywhere. So really, this is 2 equations in one. I could write it out, but hopefully you've done this before. All right. We have a -12 plus 3, which is what? -9. Is less than. In the middle, we have a 3x. Is less than 15 and 3, 18. Good. Now, again, we want to isolate the x. What should we get rid of? What do we want to divide by? 3. We're going to do that not only in the middle, but everywhere on the left and the right-hand side. Divide everything by 3. -9 divided by 3. -3 is less than, x is all by itself, is less than 18 divided by 3, 6. So here is our inequality solution. But we want to graph that. And again, I want you to understand how to graph things. God bless you. So on my horizontal number line, I need a 0. And what are the other 2 numbers that we're interested in? -3 and 6. And -3 would be on the left side. So -3 is on the left, and 6 would be to the right. All right, positive land over there to the right. Okay. So what we have here is a compound inequality. I want you to be able to read them individually. And so I'm just going to look at this left side inequality, making it purple. And again, I'm not going to use x because x doesn't really mean anything. I'm going to replace it with any number any number, remember you always start here with the variable, so I'm going to read to the left here. Any number, you'll notice what side of my inequality do I have? The big side, the open big side. You see it? My variable is closest to there, the big ends here. So we say any number greater, any number bigger than -3. Where are the numbers bigger than -3? To the right of -3. We're going to use an open or closed circle at -3. Open circle. And we want any number bigger than -3, and bigger would be to the right. So we're going to shade that to the right. Now, I have to read the other side of the inequality as well. So I'm going to do that in red. And again, I'm starting from the variable. I'm going to say I want any number. Now, closest to my variable is the little side of my inequality. So any number littler than 6. Where are the numbers littler than 6? To the left of 6. Open circle at 6. And we are going to shade to the left of 6. Now, here's the kind of weird part that you really want to make sure you understand. Didn't I just shade the whole line? Kind of did, right? Well, that's not exactly how that works. We want any number that satisfies both of those inequalities. Numbers that work for both. And so the solution is actually where they overlap. And that's actually a really good thing to understand. It has to work for both. So what numbers work for both inequalities, the red and the purple? Between, right? Yeah, that's where they're both shaded. We got red and purple in between 3 and 6. And so that is the solution. We sometimes read it that way. All the solutions, all the numbers between -3 and 6. And those are the solutions. Does that make sense to you? So in this, it has to work for both, right? That's the overlapping area. Okay? Questions on that? All right, we got one more. Last one. What's different about this one? There's an or in the middle. Yeah, it's kind of the same thing. We're really just solving equations, but there is an or in the middle, and that's an important or. But really, we just have 2 equations that we're going to solve, or rather 2 inequalities that we're going to solve. All right, so the first inequality, -2x plus 7 is less than or equal to 3. What should we do first? Subtract 7, absolutely. So we have -2x is less than or equal to -4. Very good. Now what do you need to do? Divide by -2. What do you have to remember when you multiply or divide by negative? Flip the inequality symbol. Whenever you multiply or divide by a negative, you must flip that inequality symbol. Very important to do that because we're saying it's the opposite, so we need to do the opposite of everything. That's going to give me x is greater than or equal to +2. So there is the left-hand side solution. I need you to make sure that you always bring down that or in the middle. That's a really important or. And now we're going to go ahead and solve the right-hand side as well. So what should we do first? Subtract the 5. So that gives me 3x is less than -3. And then what should we do? Divide by 3. Do I need to flip the inequality here? No, I'm dividing by a positive value. I don't have to flip that inequality. It stays the same. All right, negative 3 divided by positive 3 is negative 1. Good. So there is my solution. I'm going to graph it. Of course, I want to have a 0 marked. What are the other numbers I'm interested in? 2 and negative 1. So I'm going to put negative 1 on the left, a 2 on the right. And let's see, at the negative 1, what kind of dot should I use? Open or closed dot? Open dot. Open circle. Good. And I'm going to read this. Any number smaller than negative 1. Which direction should I shade? To the left. Numbers smaller than negative 1 are to the left. All right. Now, over here, what kind of dot am I interested in at 2? A solid dot. Very good. Because it's got the equal to bar, equal to is included. So we want to use a solid dot there. And as I read this, I'm going to say any number, I'm on the big side, bigger than 2. Any number bigger than 2 would be to the right. To the right. To the right. No, baby. No, sorry. Okay. So, that was an old song. You remember that song? Were you guys alive in that song? I don't know. You would have been like 5. Okay. All right. This is the solution for any kind of OR problem. And the way I like to remember it is that it's like oars in the water. Oars as in like on a rowboat. So you got your little hands on the oars, and these are the big paddles sticking in the water. Do you see it? There's a play on words, as in oars in the water. Okay. So yeah, OARS. Yeah, I know. They should look like that if you're doing an OR equation. Okay. This is a mathematical OR. It's like when you go to a restaurant and they're like, you're ordering your side, and they're like, do you want fries or chips? What does that mean, fries or chips? One or the other, but not both, right? Okay, so these solutions work for one or the other, but they're not going to work for both at the same time. Does that make sense to you? All right. All right, ladies and gentlemen, you may work on task practice 9. All right, ladies and gentlemen, please remember, I would like you to write your name and your seat number on your paper. Your name and your seat number. And CP9. Make sure it's titled CP9. That's all you need on the heading. Oh, you'll be able to finish that. Yeah. All right. Here. Multiply by others. Very good. Good idea.
Well, what do you guys say? I can't. Ooh, Saints? Alvin Kamara? That's what I was gonna say.
I'm barking.
Yeah, we picked up autumn.
Well, what do you
Bruh. No, keep doing.
Okay, that is the shooting in your right outside my house.
Brown, is that AB?
Yeah.
Oh my god.
See, I can't pick anything up without
Oh shit.
So far, so good. How do you get rid of that fraction? Multiply by the reciprocal. Multiply by the reciprocal. So multiply both sides by it.
Alright. I marked all the ones I thought were there. The little line.
What's the reciprocal?
Oh,
Just
wait a second. I put down 30 here. You're saying 30 and I'm like, what? This? Would you get it?
No, you can't
Bruh. Bruh.
I was going down in my neighbor. That's why I said down. It's a pretty
Yeah.
And younger mom.
No, it's not.
Don't forget to grab.
I had the first pick on his first trip.
Yeah.
No, you don't know anything. You know nothing.
oh yeah.
Bruh, I take Von Miller. You're Yo, check it out. He's
No. Any number.
I don't know how I see what makes
No.
Thank you.
Yeah. Can't compete, bro. Can't compete.
I feel that. Play with you.
No, I'm about to do one right now. Huh?
And I didn't even And
Just like the patience.
very small. I won.
Y'all should pick good players. Y'all. Look, hey, me and you, Fabian.
Yeah.
Me and you. Oh, but Diego kind of just wants each other. I didn't mean that.
So that was
Bro, I would have chose Kyler Murray. Maybe Russell Wilson. If you would have put Russell Wilson, I would have chosen. And no, because Russell Wilson is better than Patrick Mahomes. I don't know. He just has a stronger arm. So Seahawks. What?
wow.
No.
No, I said
He's gonna watch this year. T.Y. Hilton.
Remember, you can check the odd numbered questions in the back of your book in the yellow pages, yellow line. Yes. I'm gonna land here with. Yes.
It's funny when you see it. Yeah. I can't do that. It's 1:35. Oh, the security guard.
I just wanted to make sure. They got away.
Which side?
That's not an option.
You don't think that
This one? No, that's reduce the corrections. Again, you do have a test on Friday. Definitely gonna want those calculators. Really helpful.
or there's
Did I copy this? Do you subtract?
And so when you read this, you're going to read from the variables.
Yeah, he's nothing.
Read. It's not
What?